Okay. Yeah, so I think we can start. Yeah. Okay, this is the first slide. Oh, yeah. So so this workshop is about the scripting in an effect house. So you guys probably already know like effect house has supported the graph, which is the Vero scripting for a long time, as the way we program our own logic. However, it as the effect evolves, we want to make the effects more kind of like to extend the compatibility, to extend the kind of like the possibility of the effects. So we introduced the scripting. Yeah, and let me do some brief introduction about it. So the first, I think probably the small is fine. Yeah. So um the first one, the first point is that this scripting API is built on top of a new it's like a completely new APJS framework. Uh, um, these APIs are with a it's kind of like a better technical design, which consists of better security and also more kind of like compatibility, and it can provide more kind of like much more APIs and kind of like connect to more functionalities in the effect house uh, rather than the graph nodes. Yeah, and then it also enables more kind of like interactive and extensive behaviors, like because you guys can code your own logic. And as we know, like coding is limitless, right? So we can write our own code. And because the code can have like limitless freedom, and you can write your own kind of like algorithm and pack your logics into the utility classes, and then import them, and then make kind of like kind of a reusable code. Yeah, and it's also it can have more readability than the graph. Yeah, and also we can attach the scripts to seeing entities in the inspector. That means it is directly connected to the ECS design pattern of the 3D engine, so that it can run under the system's triggers, just like how it works in the other 3D engine, like I mentioned here as the fourth point. You guys probably already familiar with some other 3D engines like Unity and Unreal and Lens Studio or any other ones. But it's kind of like we do something similar so that it can down to the very original way of how the 3D engine works, right? So because it just directly explode these kind of like update and on start and kind of like on init and on late update or etc. in the future that we're gonna support. So these ones are kind of like more kind of like system oriented, and it's more tied to the system. And yeah, it's just like closer to how it works actually in the 3D engine. Yeah, and then the other point I want to mention is why we choose scripting over the Vero scripting, which is the graph, right? So because we want to tame the graph complexity, like this kind of like the screenshot, and I think this is from one of our creators to make some great effects, but the readability is kind of like very tough, and then as the effects can become more complex, and I think it's going to be more complex in the future, and the graph becomes very hard to maintain. So as we mentioned here, it just to provide a visual kind of like a visual side, visualize the logic as the flow chart. However, other ones are just like limited when it becomes complex. For example, like the board size is always limited because it has a limit size of board. You can only like see part of it, and the complex logic is hard to read. So yeah, and because the nodes are not atomic enough, it's very hard to debug. And it's kind of like it's not atomic, so you probably have to experience like to make some very simple logic by some kind of like a lot of nodes to implement just a very simple logic, because it's kind of like to implement some logic out of the node library is very hard, right? So however, in the scripting, we are coding ourselves, and it has some ultimate kind of like customization. And debugging is of course supported because it's coding, and then we can sustain the API release by just like push a lot of APIs in one new version of EffectHouse, and you guys can just use the new APIs. Yeah, and it's more easier than the graph nodes releasing. Yeah, that's the thing. And I see there are some comments. Probably. Oh, sorry. This is the. It's not the comment. Privacy effects looks nightmare. Yeah, agreed. Yeah, because I'm one of the developers of graph system as well, and it becomes like even for ourselves, it's like it's hard to read. It's hard to use graphs by the graph developers. So yeah, that's the truth. And yeah, that's focusing on the scripting today. Yeah, and scripting is pretty easy in the EffectHouse, and it has 4 steps. One is to, of course, you have to install the Visual Studio Code as what we support right now, and this is a very common used third-party IDE and worldwide, so it's very easy to download and then to code in TypeScript. And also after that, you set up the environment for the APJS API, and then you just create a scripted asset in the EffectHouse, and then attach the scripted component. So when you attach the scripted asset, it becomes a component. So yeah, and then you can start writing code. Actually, this third step and fourth step can be switched, because as long as you already created the script, you can write the code at any time, because we support the hot reloading. Yeah, and let me do some quick demo to have this like created for you guys, and let you guys see how it works. So I'm using the current, I think this is the current latest version, right? For 4.1.1, 5.1.1. Yeah, and then we create a new project from here. Okay, so we don't have the material in this project yet. So yeah. Okay, so this is the default editor window, and then we're gonna start from here. So what we are going to do is, how about we just create a cube first, as we can have as a scene object, a very basic scene object, and then yeah, you can see this is very like orthographically oriented. So we are gonna make a very simple material, and then set this to some color, maybe pink. Okay, and then I'll make this as the material of the cube. Okay. So how scripting works, we will create a script first. So there's an asset panel here. So script is actually an asset and in our project. So whenever you create a script from this, kind of like the menu, and it will create a new scripted component here. So you can see when you click on the creating new script, it will create a new script asset here. and then it will be in the asset folder of the project. So I will show the directory structure later. So yeah, this will be the inspector. What the inspector shows is the code preview. It will we already have the default kind of like several lines of code set up here for you guys. And then if you click on this button opening external editor, you should be able to install you should be able to open the installed Visual Studio Code. So in my slide, in the next slide, I have some tips about scripting first. So when you install the VS Code, you can install the JavaScript and TypeScript nightly as the helper plugin to code with the syntax highlighting and also some runtime coding analysis. And I will open this external editor directly because I've already installed that. Yeah. So when you click that button, the VS Code window will pop up, and then this is the initial template of a basic script component. So this will extend the APJS.basic script component. You can see APJS is the name of our API. So we wrap all the API functions or any kind of like properties or anything in the APJS namespace. So everything is in APJS namespace. And you can see there is a decorator here that is marking this as the component. So this is to identify this script is going to be compiled as an actual component. But otherwise, if you want to define something else from top like the enum or any kind of like other global like relative to the script itself, global properties or variables, you can do it there, but it's not marked as a component. Yeah, so that's the thing. And then there is a onStart and onUpdate right now, which is supported. And onStart is, as the name suggests, it will this is a callback, and it will be run by the system once when we start the sticker in the runtime. So everything here is run in the runtime, not in the editor, because can I search for something like APJS resources to learn more? Yeah, I just mentioned. So this is the API's kind of like the official web page in our Effect House web page, and it has an API reference when you click on the learn here, and then everything is here. That these ones are the current version that we support, and it has the lists of all the functions and also how we use it and the types, yeah, and the introductions and some code snippets to demo it. So everything is here is what we already support in our release versions. And we know that this is going to be evolved as the time. So when we release new versions, this will be posted here. Okay, so yeah, and back to the code snippet. Is the Vero scripting going away completely? No. So this is coexisting with the Vero scripting, because Vero scripting has already been very functional complete, and everything I think right now in the Effect House is very highly evolved. And however, I think the complex projects is hard to make by the Vero scripting. So what we suggest is that people can make easy kind of like the simpler projects through Vero scripting, because it still can be benefit from the visualizing kind of like the graph. However, in the complex projects, we suggest scripting right now. Yeah. And let's see others. The file has plans to release a specific plugin extension for VS Code, or yeah, because APJS plugin that we suggest. Because right now we are probably in the future something about AI or we are still planning it, but right now it's just the like basic support, language support should be enough for you to write code. Yeah. And is there any plan to convert the previous scripting to scripting? That's a good question. However, the APJS API is under a complete new structure of internally in technical side. So probably it's hard to directly, like, for example, like we have a button by one click, you convert a project from the graph project to a scripting project. That's very hard. Yeah. But yeah, but for the new projects, I think we can make scripting. But however, we are planning to make the communication between the data of a graph and a scripting. So which means if you make a script in a graph project, and the output of the graph, or like you can pin a graph, you can pin the scripted properties into the graph or something like that. You can read and write from the graph. That's probably what we are gonna do. Yeah. And yeah, maybe I will answer these questions later, because yeah, we gonna do this demo. Yeah. So on update is called every frame. So because it's every frame it can be different. So the times can be different. So we pass in the delta time, just like what the Unity does. So we pass in the delta time, and it is called every frame. That's it. And then let's make something onto this cube. Yeah. How about we just make it rotate? Because right now we are still developing the feature that we show the properties. Like if you define some property, for example, like private, for example, you want the cube, right? So cube transform, and it will have the type of APJS.transform. So for example, you want this to show here, just like the game engine does. Show it here as a property, and then you can set the scene object into it. But we are still developing that. It should be done in the very recent versions. But we in the 5.1 we still didn't support that. So I will do some workaround to get it done. Yeah. So let's see how it works. We're gonna have some global functions to do it. So this dot cube transform is, I will get it from this dot get scene object, because when this script is attached to any component, it can get the scene object from it, and then get the parent scene, which is the main scene. And then we find the scene object by name, which is very similar with Unity's. And cube, the name is cube. Okay, and then we get a component. I know this is a little bit kind of like long, but right now we have this workaround. At least the blocks people from scripting. Yeah. APJS.transform. So after this line of code in the onStart at the beginning, we will get this transform from the scene. So we get the cube's transform, and then yeah. Also, let's see whether this is compiled. But how do we see whether this is successful to get this transform? We actually have the console. If this is done, and we can print this cube transform name, something like this, and we already support the console window here for you guys to debug and print anything like in the code. And if you click on the console, it will be popped up as an independent window. And because we just introduced the custom layout, you can pin this to here. And you don't want to see the Vero scripting. And then this will indicate like we already compiled successful. And let's see whether this successfully gets from this. No, because this is not attached yet. So we attach the script from this add component menu. So script component, new behavior script. And this is the same name here. So this is the default name. Let me just maybe rename it to my script. And when you see it, my script is renamed. And you can see that this preview has this class name also renamed. So you need to reopen that because the third party IDE won't retargeting that script. So you will open that and it is automatically renamed. And then we can attach this by going to the add component, my script, and attach that. Okay. And then let's see if this works. We kind of like, we can skip this log first. And we just get the transform. And then we are going to, can I explain what I just did? Because I want to get the name of the transform. However, the transform itself is a component. So it cannot, maybe the name is undefined here. So we are gonna have the name from the scene object actually. Yeah, so if we want to have the transform, we are gonna get something else. Maybe we can have this dot kind of like the transform has a position, local position dot x, and then we probably gonna print a 0 here, right? So that's the thing. And then gonna remove this log, and then we have kind of like some idea to rotate this cube a little bit. So in an update function, we can like add some tiny kind of like offset per frame to let it work. And so let's see if we actually get this cube transform, and then we can have the current angles is kind of like cube transform dot local position dot local rotation actually. Because the rotation is a quaternion, so it's hard to understand each of the kind of like the members X, Y, Z, and W. So usually we just convert that to Euler angles, and then after that we have set the new Y because we want to change the Y per frame, and then let's see. So we have the current angle dot Y because current angle is actually a type of, when you hover on it, you can see the type, which is APJS dot vector 3f, and then we can let's see, add some very tiny value here because it's a radiant. Radiance is like 1 point something is 90 degree. So it's new. I will say new angles. Let's see. We're gonna have a new vector. Angles. That's new Y. current angles .z. So this is the new Euler angles of the kind of like rotated by a tiny offset, and then we can set that to the local rotation to be the. We have a helper function to set Euler angle into a make from Euler angles here. So quaternion.f, there's a static function here that is making new angles. Okay, and then we have to update and see, we can try to see if that works. Okay, it rotates. Great. All right, so this is a very small demo that we use to operate the transform. And let me go back to the slides and see. What the other things I want to mention is you can already see the script name, and when I kind of like rename it will be synced automatically. And we actually support JS utils if you drag some JS file and into this asset panel, and it will be imported by the EFET house. And I would suggest don't do this in the Finder or like the file system directly, because we have to drag into the EFET house to let the EFET house do the importing. And then after that, the JS will be a util class, and then you can write something like if in this, you can write like the import kind of like my utils. For example, your util class called my utils.js, and from the name, which is the my utils, something like this. If you have the JS file, yeah, and then you will be able to use those util classes and the functions, yeah. And then we already have demoed the console.log, and then the script will be in the asset folder like this. So you have the project directory, and you will see the scripts in the asset directory. And if you can have some subfolders here, you can have them, and then it will be shown in a directory projects explorer. Yeah. Let me see what you guys are asking. Product and already implement scripting. Yeah, great. And since we can have access to scripting, it's gonna be very, very useful. Okay, great. And then what is the language that you would recommend for us to use? The plan to support TypeScript or JavaScript more. So for the script itself, right now we support TypeScript only. So because TypeScript is more secure and more easy to manage, and it is encapsulated into the compiler. So we support TypeScript, and the utility classes, which means you import something that you use in your script, can be JavaScript. For example, like if you want to wrap something like the mathematics calculation here into a util class, you can do that. Yeah, and then let's see if we have some other ones to show. So let's make a small game here, and we are going to do some. Oh, sorry, haven't said thank you yet. Yeah. So okay, let's see. I'm going to open some project that I have already set up the environment for. So this is based on a template, which is a physics game in our template library. so which is called Desert Dash. And I just use the Desert Dash's kind of like the assets here, and then remove the graph actually, because I still have a graph here because we haven't supported the collision events yet, which is going to be supported very soon in our new versions. So this is going to be detecting the collision events for us. But just the detecting collision events, we haven't written anything in the graph that we can trigger the move of the ball yet. So we want to make a small game to make the ball like roll on these platforms, and finally got this lollipop hit to win this game. And if we can to see if we can hit the stars actually, because the stars has some could have some special effects like as you define. Yeah, so let's just start this first. And what I'm gonna do is I'm gonna attach directly as what I have said already set for our demo today. So I'm gonna directly attach what I have already set for these properties, and these properties are actually gotten from the kind of like the workaround that we use instead of the UI property entry. So you guys already see this kind of the logic in the last demo. So this is to make all of these scene objects and the images, and then get these images from the name as what we did before for the cube. And yeah, so I think we have to do this right now for this current version, but in the future we will be able to have this from the UI, and then assume that we already get these objects. So these objects are just the play ball. The most significant is the play ball, and then a follower, which is what we want to do, is that when the ball goes onto the platform, we want to have a third part, kind of like a third, kind of like a camera that is following the ball, right? So it should be a third person perspective for this camera. So I made a follower, which is the camera's scene object, and then you guys can see we already get these objects, and what we are gonna do is we want to set a touch events, because this is a game and we want to take the user inputs. If we set the kind of like direction by dragging on the screen, it will be going forward, and then we want to go right and left by the touch. So actually we already support the touch events. So let me introduce how we can do it. So actually we can have this. So we can have another function which is called onTouch event. And we make this a property function and pass in a apjs.event. So this is the type that we passed in, which is the event, and this will be set up later as we can subscribe it. And in this touch event, when this touch is detected, we usually have the touch info here, and then we get it from the events event.arg 0, and then as the apjs.touch data. So this is the type of touch data. And then we got the touch info, and we can have because the touch info has several phases, and we want to get whether the touch info is currently at begin or end or like move or anything. So we're gonna have the touch info dot face, and we're gonna have the first case, which is the begin. So at the beginning, we want to see what our mouse is at. So this is actually the screen position that it returns from the touch info. So as the first case, as the begin, and then the second case should be the end. The face end. So we're gonna have, this is gonna be more complex because when we drag and like touch something like this on the screen, we want to record record our kind of like activity on the screen to see if the end position and the offset of the end position comparing with the beginning position. So if we remember this in position at the beginning, and then we need to take the kind of like take the difference here. So what we are gonna do is we're gonna have the position dot subtract, because this is the APJS vector. So any vector can have the subtract with another vector, and then we got the move vector, which is the difference. And then after that, we can have something like logic to compare it with some threshold value to make the move of the ball. So we already support the physics physics API here. So we got the APJS rigid body from this on start as here, as we have the rigid body. And then the ball rigid body makes the ball like kind of like automatically falling down when there's a gravity. And then it has some physics, basic physics, like the force and also the acceleration. So we're gonna do add force to the rigid body when there is a kind of like a touch on the vertical direction. And if there is a touch on the horizontal direction, we will see whether the y difference is negative or positive to judge whether it's going to the right side or the left side. So that's what it basically does. If it goes to the left side, it will add force here to the positive direction of if it is on the right side, it's positive direction of x. If it is on the left side, it's negative. And then on the z direction, actually horizontally, as we can see it, this direction, it will go vertically, which means in the 3D space, it will go forward. Okay, so by this means, after this is done, the touch event is set. However, we need to set some subscription here. So our APJS API has a subscription that you can use in the onStart. Usually, you can use it at the very end of the onStart, which is the get global emitter.on, and then you just change this variable here to be the same function name as the onTouch event. So you don't need to worry about this unsubscribe because we haven't introduced the onDestroy or any others yet. So yeah, make the save, and then restart and then you can see if I drag it on the screen, the ball starts to move. Okay. Yeah, that works. However, the thing is that, as I mentioned before, we need to have a third-person camera to follow it, because when it goes farther away, we cannot follow it. You can see it goes too far away from here. So something like that needs to be done. What we are gonna do is that we need to have a camera forwarding logic as the ball goes. So it should be in on update. And in on update, we have a camera following logic like this. So if there's a ball follower, which is the transform that I get from the scene here, in the future, you can get it directly from the UI property. And then this ball follower is the camera holder, parent of the camera holder here, which is the ball follower, this entity. If this entity goes together with the ball, we were gonna follow it because we already set the angle of the camera to like look at this ball. So let's see. We define a constant that is the difference, the offset of the current, like the initial difference, the initial offset of this third person camera and the ball. This is the can be function to declare like this. Could this function be declared like this? Even APJ? Yes, I think so. Yeah, this is just what I used for as a property function, but you can define it as a regular function. Yeah, and then if you put it as a regular function, you're probably gonna do this instead of this one. Okay, so or I maybe I don't think so. It's the same thing. Yeah, probably this will, but the compiler will give you the hint if that one anyone is correct. Yeah, and then we make the offset vector, and then we set the world position of this to be always the one that the different kind of like the offset between the follower and the actual the ball. Yeah, let's see how, if that can work. You see? So it will keep the fixed kind of like an offset vector between the follower and the ball. And if you make the ball moving, the camera will follow it. Okay. And then let's do something else. So the ball can move, and we can follow the activity of the ball. And it seems like it's already very playable. And we'll make something interesting here. How about we just change the look of the ball when it hits the stars? So what it does is it detects each of the collision of the different objects, such as the stars, and returns a different kind of like data from the collision event. In the future, when we release the collision event API, you guys can directly use that in the code. However, right now we use the graph to pass out the collision event here, so that we are unblocked by the detect the events. So what we're gonna do is like something like this to detect whether it hits a star. So in the on update, every frame I will check whether the collision indicator is set. So what it does is that if a star is hit, for example, like the first star I mark it as a detector 1, the transform will set X to be 1 instead of 0. So that's the workaround. So if you detect a 1 here, and then that means this collider is hit. So in the future, they will be done by the collision events. But right now, we have to do this to detect the events. And yeah, so if we will say like if the local position.x is greater than 0, that's what I set up. It's not the system. Okay, so I set when the collider is hit, the x is greater than 1, and then I will detect that in the onUpdate function. So that means it is hit, and then when everything is get correctly, we're gonna get the mesh renderer of the ball. So it will be the APJS mesh renderer that we got from the onStart here. Get mesh renderer from the name, just like what we did before. And then you get the main material of the mesh renderer and set a texture. So here's the thing. So the uniform name is fixed in the kind of like in the effect house system. So the way you get it is when you click on some of the material or kind of like, I think it's the texture. When you click on the texture, I think there is some way, for example, like in a graph, I think a graph can help you find what is the texture here. So if you get a texture, you're gonna see the uniform name from this graph. I think this is the current only way like you can see what's the uniform name of each of the texture. But in the future, we'll make some great UIs here to let you guys can explore each of the uniform of this material. Yeah. So yeah, so we're gonna have this here and then assume we already know the name and the set texture, the uniform name to be the texture one. The texture one is what I already preset here. In the future, you can directly link this with UI and then drag your favorite texture here. But right now, it's gotten from some scene object, which is an image. So that's basically a workaround. Yeah, and then we're gonna add something very similar with this for the second and third star. So what we're gonna do is we have second, we have the third star. So what this code does is that it will change the texture to some other texture when it hits a star. You can see like I set a texture to something else when it hits a star when it detects the colliding in the scene. So let's see how let's see if it works in a scene. Let me start. Let me play this game right now. And the first scar, when I hit it, it should change the look. Oh, sorry. It's very hard to play. Yeah. Should add some horizontal force. Go back. Boom. It changed the texture. Oh, it changes again. And it hits the final destination. So if you want to have some like winning animation or something like thing here, you can do something similar here to detect like if I suggest the winning condition should be done at the beginning of the update, and if some like win hit or something like that, and then you're gonna have some animations, right? So yeah. Okay. I think that's about it. This is a physics. This is a demo of our physics system currently. It covers like the rigid body, the collision, even though there's no collision event yet, but I think in the upcoming versions, we will support that very soon. And yeah, I think that's the demo. And we can have the Q&A session. Let me check your questions. Could just use variables for this if else statement, setting the force, right? Yeah, of course. Yeah. And then just to set my code is just for demo. It's not, of course, it's not perfect code. It's just like something I can write quickly here and then to demo the functions of the APJS API. But you guys can make this very good in the future by defining the enums, defining the pipes there, and then make everything about the mathematics calculation, wrap them in a util class, a util or util JavaScript file, and then drag it into it, and then you can directly reference them so that it's easier to reuse. Yeah. I didn't get the event part. Where is the function being called? Okay, so this onTouch event is a function that is you subscribe when the onStart is called. So when onStart is called, that means the script will put this function into a subscription, which means every time there's a touch in our system, you can see like we have the apjs.touch as the kind of like event, and then you can see like event emitter.on. That means we have turned on this subscription of the onTouch event, and this is the back kind of like callback. Yeah, there is an event manager. Yeah, right. So apjs.event manager is the global kind of like the manager that you can set to support it here. So everything is, I think it's event manager is here. And there is some very detailed information about event manager. Yeah. And everything here is when you have the touch, it's very general. It can be anything. And you can just do, we not only just support the touch event, you also can support kind of like the touch force, even kind of like how much you press on the phone, something like that, and make very interesting effects maybe. Yeah, and yeah, I think that's about it today. And let's see if there are other questions. Most like Unity. Any plans on sync the same panel with the preview at runtime? What does that mean? So same, let me try to understand it. Same panel with the preview. Okay, so you mean the inspector? This thing is you mean in fact house this thing is not synced in the runtime, right? That is because we have Do instance in our 3D engine. This everything you showed here is in the editor time, and the scripting and the graph is actually a runtime progress that we only run in the tool, like we only run in the preview and in the sticker in the if you upload the effects onto the TikTok, it will be running directly as the runtime. It doesn't support the editor time stuff because this has to be in the effect house. So what we are doing is that we separate these two states, and we only update the runtime stuff that you can preview in this preview panel, but it is different data with what it shows up here in the editor. Yeah, that's how it works in our 3D engine, but I don't think we have the plan yet to change that because the way we are the way how the physics engine and the system engine works is different from Unity or other game engines, because game engine is single instance. Yeah, and cross the finger. Yeah. Okay, so that's about it. Let's see whether Furina has other things to talk about, or do we have any other general questions? Native events supports in Vero scripting, like touch events, drag events. It is collision events the only event that's not supported. Touch event, drag events. I think touch event can be used to simulate the drag events, because actually you can see what I already do here is to simulate a drag. When you have drag, you just calculate the difference between the beginning and end. We actually have another case here, which is called case. We have the apjs.touch. You can see the touch face has other. It says moved and canceled. So if you have moved, it will So every frame you move the finger on the screen, it will be called. So yeah, so this will be triggered, and that can be helped to simulate the drag event. And in Vero scripting, I think there are very identical nodes that we can use for the touch event, like the screen tap, things like that to simulate that. But yeah, whether the collision events is the only event that not support, I think for those very atomic and the most important ones, yes, this is the only thing, because this is the physics events, which is different from others because others are input events. Yeah, I have a question. Do you know if it's possible to get multiple input events in custom node, like in the Vero scripting node? I don't think we release custom node in TikTok Eval. Let's see. So, like what do you mean by in a Vero scripting node? In Vero scripting node, you want to have the multiple touch. I don't think we have that because we only can detect the tap. But however, in the scripting, I think yes, because you have the let me check. So there's a touch info here. So touch info dot, it has a force, name, face, position, and touch count. This is what you asked, right? So touch count is the number of touches that is currently on the screen. Yeah. Using in scripting, there's only the execute function. Subgraph. Oh yeah, in the internal versions we have the custom nodes. Decorator. This is not in component. Okay, I think if you can access the custom node, it should be the same set of kind of like the APIs here. I don't think we have a completely different API for the custom node. So basically, the touch info will passing in everything that we have for the touch, and then we have the touch count. Is this what do you want, or it's not in component but custom code, but custom node? I didn't. Yeah, I didn't have like developed the custom node because it's by the other team. But yeah, basically I think they we share the same set of APIs. So if you can access custom node, I think this is it should be shared. But if there are more in a custom node, it's possible because custom node is actually the first step we want to support the scripting, and we released that very early ago. So that's probably more the reason why we support more in the custom node. Yeah, and I think that's it for today.